Today I'll talk about adiabatic process. An adiabatic process occurs with no heat transfer, that is Q is equal to 0. Now first law of thermodynamics, del U is equal to Q minus W. So here Q is the heat added or removed from the system, can be positive or negative. W is the work done by the system or on the system, can be positive or negative. So del U is the change in internal energy. And definition of adiabatic process. An adiabatic process occurs with no heat transfer, so Q is equal to 0. So if that is del U is equal to Q minus W, so Q is 0, so del U is equal to nothing but minus W. So now del U, you know that is nothing but NCV del T. So here from that we can write work done by the gas, and it comes from internal energy, that is W is equal to minus NCV del T. So now heat transfer, since the process is adiabatic, there is no heat transfer. Change in internal energy del U, the change in internal energy equals to work done. So here is the visual example. A gas in an insulated container undergoes expansion, doing work on the surroundings. Since no heat is exchanged, the internal energy decreases and the gas cool down. So here one example with from state to different state. So no heat transfer, Q is equal to 0. The system moves from P1 V1 T1 to P2 V2 T2. So work done, all the work comes from internal energy. So W is equal to minus del U. So that is minus NCV T2 minus T1. So heat transfer, since the process is adiabatic, there is a no heat transfer, Q is equal to 0. So change in internal energy, the change in internal energy is given by del U is equal to NCV T2 minus T1. And relationship between pressure and volume, so P1 V1 to the power gamma is equal to P2 V2 to the power gamma. So here gamma is nothing but Cp by Cv, that is the adiabatic index. So example, rapid expansion of gas in an insulated container. Work is done by the gas, causing the temperature to decrease. No heat is added or removed. Here I am taking one numerical example. So we know that for adiabatic process, no heat is transferred, so Q is equal to 0. So here is the numerical example. Initial state P1 is 100 kilopascal, V1 is 1 meter cube, T1 is 300 Kelvin. Final state P2 is 200 kilopascal, B2 is 0.8 meter cube, T2 is 500 Kelvin. So number of moles, first we have to calculate. Using ideal gas law, we calculate N is equal to P1 V1 by RT1. So P1 is here 100 into 10 to the power 3 Pascal into V1 is 1 meter cube. R is 8.314 joule per mole Kelvin, and T1 is 300 Kelvin. So after doing the calculation, we will get N is equal to 40.1 mole. Next, here for adiabatic process, for monoatomic gas like helium and argon, Cv is equal to 3 by 2 R. So that will be given R is equal to 8.314. So that will give 12.47 joule per mole Kelvin. Since no heat is transferred, so work comes from internal energy. So W is equal to minus NCV T2 minus T1. So N is actually 40.1 and CV is 12.47 and T2 is 500 and T1 is 300. So that will give 100 kilojoule. So heat transfer Q is, we know for adiabatic process, that is 0. So change in internal energy, so del U is nothing but minus W. So del U will be NCV del T. So similar way we can calculate that del U is nothing but 100.009 kilojoule. That's it.